In a remarkable piece of serendipity, NASA's Hubble Space Telescope captured a comet in the act of breaking apart, an event astronomers have long hoped to witness. The object, designated C2025 K1 ATLAS, was not the original target of the observing program, but was selected after the primary comet became unavailable due to technical constraints. Over 3 consecutive days in early November 2025, Hubble used its Space Telescope imaging spectrograph to take a series of short exposures that revealed the nucleus disintegrating into at least 4 distinct pieces, each surrounded by its own bright coma of gas and dust. From the ground, the fragments appeared as blurry knots, but Hubble's sharp vision resolved them as separate bodies, providing an unprecedented view of the breakup process just days after the comet passed closest to the Sun. At perihelion, the comet entered a region inside Mercury's orbit, where solar heating and tidal forces are extreme, conditions that often trigger fragmentation in long-period comets. Scientists estimate the original nucleus was roughly 5 miles across and began to crack apart roughly a week before Hubble's observations. The images show one of the smaller fragments undergoing a secondary split, illustrating how cometary material can fracture repeatedly under stress. By tracing the fragments back in time, the team reconstructed the timeline of the event and found an unexpected delay in the comet's brightening after the breakup. The leading hypothesis is that fresh ice exposed by the fracture initially released little dust, and only after a thin dust mantle formed could the reflected sunlight increase sharply, explaining the lag. Spectroscopic analysis of the gases released shows an unusual composition, with notably low carbon content, suggesting that this comet may preserve primitive material from the early solar system that has not been heavily processed. The observations also raise questions about how quickly dust layers form on freshly exposed ice and how that influences coma development. Researchers plan to continue monitoring the fragments with Hubble and other space telescopes to track their evolution as they drift away from the Sun, now a cloud of icy debris heading out of the solar system. This discovery adds a valuable data point to models of cometary disruption and offers a rare window into the makeup of the solar system's building blocks. The Hubble telescope, now in its 4th decade of service, continues to provide groundbreaking science, underscoring its role as a workhorse for astronomical discovery. The latest news you find here.